Today's lesson is Module 4, Lesson 7, Replacing Numbers with Letters. In today's lesson, we're going to be working with various formulas that we use in geometry. And the reason why we are doing that is so that we can practice substituting numbers for variables. So the first formula we're going to look at is the area of a square. The formula for area of a square is area is the same as the side squared, because we know that all four sides of a square are the same. So the first thing we want to do is we want to write out our formula. So A equals S squared. Then I'm going to continue with A. A stands for area, equals, and this time instead of writing S, I'm going to write down the size of that side, which is 4 centimeters. And then I have to remember to add in my subscript 2. Now what I have to do is write out what does 4 centimeters squared look like. Remember, when we square something, it means to multiply it by itself that many times. So 4 centimeters squared is the same as saying 4 centimeters times 4 centimeters. Then the next thing I'm going to do is I'm going to first multiply 4 times 4, and 4 times 4 is 16. And since centimeters times centimeters, I can't write numbers for that, so I'm going to write centimeters, and since there's 2 of them, it gets the squared symbol. So the area of a 4 centimeter square is 16 centimeters. Next, we're going to look at area of a rectangle. What we know about the area of about rectangles is that opposite sides are the same. For the formula for area of a rectangle, we're going to look at the length and the width. This is the length, this is the width. So for area of a rectangle, we multiply those together. So the first thing I'm going to do is write out my formula, A equals L times W, and then I'm going to substitute my numbers in for my variables. So for length, that's 8 centimeters times my width is 4 centimeters. So the first thing I'm going to do is multiply my 8 and my 4, and 8 times 4 is 32. And then centimeters times centimeters is the same as saying centimeters squared. So the area of this rectangle is 32 centimeters squared. Let's go on to the next page in our notes. Please remember that you can pause these notes. You can go back, listen to it again, take your time to make sure you get everything written down. The next formula we're going to look at is volume of a rectangular prism. It's a prism because it is 3D. That means it is not a flat shape. It is 3D. It's rectangular because that front face is a rectangle. So the volume is volume equals length times width times height. This is your length. This is your width. This is your height. So the first thing I do is I write out the formula, volume equals length times width times height. The next thing I do is I substitute in numbers for each letter. So since 2 centimeters represents my length, I put in 2 cm for L. My width is represented with 3 centimeters. And finally, my height is represented with 8 centimeters. So the next thing I do is I multiply just my numbers together. I'm going to do this work down here so that you can see. I have 2 times 3 times 8. And 2 times 3 gives me 6. And then 6 times 8 is 48. So my volume is 48. And then you can see I have centimeter, centimeter, centimeters. So I'm going to go ahead and write down centimeters. And then cubed, because I have 3 of those. So the volume for this rectangular prism is 48 centimeters cubed. Before we go on to the student book, I just want to remind you that perimeter is the outside measure of an object and that you add all sides. So now if you go ahead and take out your student book, again, we are on module 4, lesson 7. So up at the top, it should say 6.4, lesson 7, replacing numbers or replacing letters with numbers. In this first part, in this example 1, we're going to be using this square here to answer the following questions. So it says, what is the length of one side of the square? So since it's a square, remember, I only have to count one side, that all sides should be the same. So I can count this side, 1, 2, 3. So I would say this is 3 units, because I don't really know how big each one of these squares are. So I'm just going to call them units. So 3 units. Next it says, what is the formula for the area of a square? If you remember in your notes, we said that the area of a square is A equals S squared. So now it says, what is the square's area as a multiplication expression? So now they want us to write this out. So over here to the side, we're going to go ahead and write in that formula. And remember, in our formulas, we have to change this variable with the number that's represented in the object. So A equals 3 units squared. So that's the same as saying A equals 3 units times 3 units. This is the multiplication expression. So 3 units times 3 units. So what is the square's area? Well, I multiply my 3's together, and 3 times 3 is 9. And then since I have units and units, I write down units, and then I give it the superscript of 2 for squared. So the area of a square is 9 units. Next it says, we can count the units. However, look at the other square. Its side length is 23 centimeters. That is too many tiny units to draw. What expression can we use to build to find the square's area? So if you remember, we said area is the same as sides squared. Next it says, what is the area of the square? Use a calculator if you need to. So now we're going to substitute in for that S squared, the 23 centimeters. So A equals 23 centimeters squared. Then I have to write out that as a multiplication expression. So 23 centimeters times 23 centimeters. The first thing I'm going to do is multiply the 23 and the 23 together. Remember, you can use a calculator. That answer is 529. And then since I have centimeters 2 times, I represent that with centimeters to the second power. So the area of this square is 529 centimeters squared. Let's go on to the next page. On this page, you are going to complete this table using these two squares here. In the first box, it says the length of one side of the square. So they only want to know how big is one side of the square. So in this, we'll do this first one together and then you can do the second one with a partner. So the length of one side is 4 units. The area written as an expression, remember to find area, we're doing A equals S squared. So that would be A equals 4 units squared. And then A equals 4 units times 4 units. So that's what they want you to write here. 4 units times 4 units. And then to write it as a number, the first thing I have to do is multiply my two 4s together, which gives me 16. And then since I have units written 2 times, it's going to be units squared. Now I want you to pause the video and go ahead and do this one with a partner and then come back and check your answer. So you and your partner should have written that A squared was the formula, and then you're going to substitute in the 25 inches. So A equals 25 inches squared, which is 25 inches times 25 inches. And then your final answer is 625 inches. And then in your box, you should have recorded that one side was 25 inches. The multiplication expression is 25 inches times 25 inches. And then the end result is 625 inches squared. Let's go on to example 2. In example 2, this time we're using a rectangle. And remember that the area of a rectangle is area equals length times width. So in this example, they want to know what does B represent in this rectangle. So since this side is B and this side is 8 centimeters, we know that they have the same measure. So B represents 8 centimeters. On the next part, it says, with a partner, answer the following question. Given the second rectangle is divided into 4 equal parts, what does the number X represent? So what it's saying is, since each one of these little pieces is 4 centimeters, how much would this amount be? So go ahead and answer that with your partner and then come back and check. You and your partner should have figured out that this was 2 pieces and 4 centimeters plus 4 centimeters is 8 centimeters. So the X represents 8 centimeters. It says, how did you arrive at the answer? We added the 2 pieces together. The next question, it says, what is the total length of the second rectangle? So of this rectangle here, what is the whole length of this whole side? If we add all these pieces together, what would that be? So I have 4 centimeters plus 4 centimeters plus 4 centimeters plus 4 centimeters. Or you could say I have 4 groups of 4 centimeters. Either way, repeated addition, remember, is the same as multiplication. So that all results in 16 centimeters. Next it says, if the two large rectangles have equal lengths and widths, find the area of each rectangle. So what it's saying is, if these two rectangles are the same size, if this whole piece equals 16, this whole piece equals 16 centimeters, then this piece over here has to also equal 16 centimeters. And if this side equals 8, then this side also has to equal 8. So remember to find the area. That is the length times the width. And we said the length was 16 centimeters and the width was 8 centimeters. So now I'm going to be multiplying 16 times 8, which gives me 128. And then since I have centimeters 2 times, that is centimeters squared. Next, it says discuss with your partner the formula for the area of squares and rectangles and how they can be used for a particular figure. So in this section here, I want you to just write out the two formulas. So go ahead and pause your video and then come back and check your work. So you and your partner should have come up with the two formulas. For a square, it's a equals s squared, and for a rectangle, a equals length times width. We're going to go on in exercise 2. For exercise 2, this is very similar to exercise 1, where you have to find the area of each one of these rectangles. Remember, in this first one, the first thing you need to do is to count the number of units so that you can figure out how long and how wide it is. This is the length, and we're going to call this the width. So I want you to go ahead and take the time right now to work this out with a partner. Pause your video and then come back and check your work. So you and your partner first should have figured out that this length was 7 units and the width was 4 units. Remember, you are using area equals length times width for each one. So on the first one, you should have done area equals 7 units times 4 units. And then you multiply just the 7 and the 4 together, you get 28. And then since there's units 2 times, it's units squared. So in the first row in your box, you should have had 7 units, then 4 units, then 7 times 4 units, and then 28 units squared. On the last one, you should have had area equals 46 meters times 32 meters. And then when you multiply 46 and 32, you get 1,472. And since meters is there twice, you get meters squared. So in your last row, you should have had 46 meters, 32 meters, 46 meters times 32 meters, and the end result is 1,472 meters squared. Our next example is going to be on volume. So this was the last one that we did together in our notebook. So we are going to be representing these different numbers are going to be replaced by letters. So what does L represent in the first diagram? I can see that it's on the bottom here, so I match it with the bottom here, so 6 centimeters. What does the W represent? I look for the number that coincides with the same placement of the W, and that is 2 centimeters. And then the H, its partner, is the 8 centimeters. Next, it says, since we know the formula to find volume is volume equals length times width times height, what numbers can we substitute in for the L? So L is length. So I know I can substitute in the 6 centimeters because it represents the length of the prism. What other number can we substitute for the L? Or no other number. The reason we can't is because there's no other number that matches its placement on the prism. There's no other number that matches its placement. So that's why we can't substitute in anything else. So we're going to say only one number can replace one letter. The next question, what number can we substitute for the formula, for the W in the formula? So I look at the placement of the W, and I see that its partner is 2. So I'm going to say 2 centimeters because it represents the width of the prism. Now I'm going to have to flip back and forth as I continue to answer these questions. What number can we substitute for the H? So when I look back, I see the H again, and its partner is the 8 centimeters. So we say 8 centimeters. And remember that that's the height. So determine the volume of the second rectangular prism. Remember, volume equals length times width times height. So when I go back, I see my length is 6. So volume equals 6 centimeters times my width is 2 centimeters. 2 centimeters times my height is 8 centimeters. 8 centimeters. My next step, I'm going to just multiply the numbers together. So 6 times 2 times 8. I know that 6 times 2 is 12. And then 12 times 8 is 96. So my volume is 96. And then I have centimeters, centimeters, centimeters. So centimeters cubed. I want you to go ahead and do exercise 3 with a partner. Make sure you're using volume equals length times width times height. And then come back and check your answers. So you and your partner should have worked out the formula and plugged in 12 units times 5 units times 15 units, and that is 900 units cubed. And for the other one, it should have been volume equals 23 centimeters times 4 centimeters times 7 centimeters, and that is 644 centimeters cubed. Your table should have been in the top row 12 units, 5 units, 15 units. Multiply all of those together. This multiplication should look the same as over here. 12 units times 5 units times 15 units, and that equals 900 units cubed. And then 23 units, 23 centimeters, 4 centimeters, 7 centimeters. Show that as a multiplication expression, 23 centimeters times 4 centimeters times 7 centimeters, and that results in 644 centimeters cubed. For today's assignment, you are going to complete the exit ticket answering questions 1 through 4. It is about area and perimeter. And on the back, you are going to complete area and volume examples. And number 2 is just like the ones we did in our exercises. Please make sure you're showing all work and show all formulas. If you have any questions, please feel free to pause and rewind your video or come and check with me.